Okay, so polar form. So in the last session, we started polar form. Now, Cartesian form of a complex number z is equal to x plus iy, right? So what we are going to do, we are going to take x squared plus y squared out. We call it factorize. Why specifically x squared plus y squared? Because if you draw that, that would be the radius. So this would be your z mod, we call it, and that would be x squared plus y squared square root. Yep. So this length is y and the horizontal is x, right? So what we are going to do, knowing that hypotenuse is the radius, I'm going to take that out and then accordingly I do the algebra. So I need to introduce this because when you cross multiply or when you multiply, they cancel each other. Iy divided by this. See, you can see now these two cancel, then you get the original. Now, let's go to this picture over here. So this is theta, for example. Now from this picture, define cos theta. If you define cos theta, that would be x divided by x squared plus y squared square root. Right? Similarly, sin theta, that would be y divided by x squared plus y squared square root. Okay, so now we have that. So if you observe here, that's nothing but cos theta. If you observe here, that's nothing but sin theta. Now we can replace it. If you look into this one, this is nothing but your radius. Right? You can say radius O, z mod, doesn't matter how you call it, what you call it. So this is nothing but now R cos theta plus I sin theta. Then you can see C I S. So short form of this one is R cis theta. Short form. Now there is one beauty in here. That would be, okay, if you consider cos, right? And if you consider sine, the period is the same. Cos function, sine function, period is the same. Period, same. 2 pi we call it. Right? Now, using our math knowledge, this is A, right? Using our math knowledge, what if you write this one? What if you write this one in this way? R cos, I'm not going to write theta, but I'm going to write theta plus 2 pi k. Same thing. Because after one rotation, it comes to the same point. Plus I sine theta plus 2 pi k. So you can do that. Right? So in general, if you want, you can do this in this way. R says theta plus 2 pi k. Right? So we can generalize this. Okay. O, yeah, O z is equal to R cis theta. Right? You have to understand this is more general. This way of writing is more general. Why more general? Because this talks about only a particular theta value. Because this will address a lot of theta values. Yeah? Because these circular geometries are weird, right? Why? Because it's the circular nature would be after one period it comes to the same point. You know? So this is just unique. Yeah? Okay, all good. Now what we are going to do is this. Now this is called the polar form, right? So what we understood, z is equal to x plus iy. This is in the Cartesian. In the polar, this should be r is theta plus 2 pi k. Or just theta, doesn't matter. Now, you remember, in Cartesian we discuss about z1 plus z2 minus, then z1 z2, then z1 divided by z2, yeah? So these are the variations we can have. So we are going to discuss the same thing in here, right? Okay, let z1 to be r1 cis theta 1. I'm not writing in general, but theta 1, right? So z2 is r2 cis theta 2, right? So now, if you want to do this first one, z1 plus z2. If you want to do z1 plus z2, it is going to be r1 cis theta 1 plus r2 cis theta 2. Now this cis is just a name, right? Short form, right? Now you can't do anything with the short form. Always when you have the short form, you have to think about the long form. So you write this one as r1 cos theta 1 plus r1, I would say I, r1 sin theta 1, correct? Similarly, r2 cos theta 2 plus I, r2 sin theta 2. Now you will see these two, they are real, right? So I'm going to write r1 cos theta 1 plus r2 cos theta 2, and that is one real part, plus I. You can get the next one would be r1 sin theta 1 plus r2 sin theta 2. See? So now can you see this is itself a complex, see, z plus I by form, if you want to think in that way. So that now if you are thinking of minus, it's just a matter of you are putting minus here. So then it's just a matter of you are putting minus here and minus here, right? So plus minus, this is how it works, right? Now we will discuss about the multiplication, right? This is not a big deal. So in the multiplication, what you get is the part z1 z2. If you look at this now, z1 is r1 cis theta 1 multiplied with r2 cis theta 2. I need to put a bracket. Yeah. So now this guy we'll try to expand now, right? So this is going to be r1 r2 cos theta 1 plus I sin theta 1 multiplied with cos theta 2 plus I sin theta 2. Now what we do, we bracket multiply. So if you do that, r1 r2, you do this cos theta 1 cos theta 2, then again with I here, so I cos theta 1 sin theta 2, then again I, which is this one, I sine theta 1 cos theta 2. Then again this guy, and you can see I squared, right? I squared is minus 1. Sine theta 1, sine theta 2, done. Now from here you can see this guy and this guy real, and this guy and this guy, they are imaginary, right? Right. So now I'm going to group them. When I group them, I get this. Should be clear. Right. Now, what is this? What is that? Let's go back. What is this? What is this? With the minus?
Angle.
Compounding angle. Yeah. So exactly what we have here is, see, same minus, see, same term. So this is nothing but cosine theta 1 plus theta 2. This is nothing but sine theta 1 plus theta 2. Okay. So that's the beauty. So this is R1, R2. Now you can say cis theta 1 plus theta 2. Right? So this we proved now. Okay. Now you can see what we did. Z1, Z2, R1, R2, cis theta 1, cis theta 2 becomes R1, R2, cis theta 1 plus cis theta 2, I mean theta 1 plus theta 2. Right? Now if you really think about this is multiplication, right? When you are multiplying, you can see the radiuses are multiplying, right? But arguments, they are adding. They are not multiplying, they are adding. What do you mean by argument in complex numbers? Argument in complex number means angle. Modulus of a complex number means radius. So I'm saying arguments are additive. Arguments are additive. Got it? So this is very important. So then in this situation, if someone asks, what is Z1, Z2 mod? The answer is going to be R1, R2. If someone asks, what is argument of Z1, Z2? Argument means angle of Z1, Z2. Angle of Z1, Z2 is whatever here inside. See? Now the additive, this is multiplicative. So that's a feature. We always use it. Right? Okay. So now this is our B part. Right? Now what is the C part? C part proof I'm not going to do. C part is this. If z1 is equal to r1 is theta 1 and r2 z2 z2 is equal to r2 is theta 2, then z1 divide by z2. Now what we understood previous, multiplication will give you multiplication of the radiuses. Now here division. Now this is called pattern recognition, right? If you can prove it. Then when you are multiplying, the angles are additive. Here angle should be subtractive. Simple. So this should be cis theta 1 minus theta 2. You can prove it like similar way, right? So in this case, if you need to find z1 divided by z2 mod, that would be r1 divided by r2. And if you need argument of z1 divided by z2, that would be theta 1 minus theta 2. Okay? Okay. Question. Let z1 is equal to 1 plus I and z2 is equal to 1 plus square root 3i. Right? First one would be convert to polar form. That's the first one. Second one would be find z1 z2 comma z1 divided by z2 in polar form. Right? See, hence find arc of z1 z2 and arc of c1 divided by z2. Okay, so now if you want to convert z1, so you should get square root 2 1 divided by square root 2 plus I 1 divided by square root 2. Now this you have to convert into cos, this you have to convert into sine. So you keep square root 2 here and then you write straight away this is going to be 6 pi divided by 4. Then z2. z2 is that. So z2 is going to be 2, then 1 divided by 2 plus I square root 3 divided by 2. Now you understand this is cos, this is sine. Yeah? So it's going to be 2 cos pi divided by 3. So you convert that into 6. And you have that. Now, okay, z1, z2. Now you can see this. This is A part, right? So B part, z1, z2. z1, z2. Now you know, you use the theory, right? The theory you learned before. So, you know, modulus or the radius, they are multiplicative. So 2 times this is 2 square root 2. But arguments are additive. So it should be, says, pi divided by 4 plus pi divided by 3. Right? So what would be that then? 2 square root 2. Says what would be that? So 12, 3, 7, right? 7 pi divided by 12, yeah? Good. Easy, easy. Now z1 divided by z2. z1 divided by z2 is z1 top, right? Yeah. So what is top here? Square root 2. Square root 2 divided by 2. Says, so who is in top? Pi divided by 4. So you put pi divided by 4 here. Minus pi divided by 3. Right? So if you do that, what is the answer? 1 divided by square root 2. What is the answer says?
Minus pi over 12.
Minus pi over 12. Done. Right? Sixth part. Now, argument. So obviously argument of z1, z2 is angle. So angle would be 7 pi divided by 2. 7 pi divided by 2r. Then argument of z1 divided by z2 is going to be, you go here, minus pi divided by 2. Okay, so what happened to this? Okay. Now we will start the new topic, De Moivre's theorem, right? De Moivre. Scientist. De Moivre is a scientist. Now, this is what he said actually. It's not a magic. You know what he said already. I'm sort of showing it to you. You know Z1, Z2. You saw that this is R1, R2. This is theta 1 plus theta 2, right? Yeah. Now, if you have Z1, Z2, Z3, another one, what you're going to do is you're going to multiply this by that, right? Then if you do the proof, you see this. It keeps going. Nice, right? What De Moivre said, what he said is this. Now suppose Z and Z, same. If Z and Z is going to be R squared, R and R. Okay, let me say R and R. Says theta plus theta, 2 theta. Yeah, so this is nothing but R squared, this is 2 theta, right? Now, again, observe this clearly. Z squared is equal to R squared, this is 2 theta. This is what we have. Yeah? Okay. Now, observe. Observe this. If Z is equal to R cis theta, from here you can get Z squared, right? Z squared is equal to what? R cis theta, look at this. The whole thing is square, right? Normal algebra, right? Now that is going to be R squared cis theta squared, right? Right? But, now this is the catch. But Z squared you write as cis 2 theta, right? And that means this one is equal to cis 2 theta, right? Got it? What is observation now? Observation is, when you have a power associated with the angle, that power is absorbed into the angle. See? That power is absorbed into the angle. Now that's the observation. It's pretty, you know these things. You know all of these things. It's just that observation. Okay, so now we will try to generalize it. So let Z is equal to R cis theta, right? Now, if you want to find Z to the power 3, what it would be? It would be actually R3 cis theta 3. This is our algebra work, index laws. Now, we understood if you have cis theta 3, this can be written as this. So this product we use all the time. Now, in general, if you have 0 to the power n, okay, here 0 to the power n. So now using our thing, you know that R to the power n says n theta. That's it. Right? That is called De Moivre's theorem. Right? Now we have to use common sense, right? Now we have to use common sense. What do you mean by that? Suppose, example, okay? Suppose you have z is equal to 1 plus I, simple example, to the power 3. You have that. You have to simplify or do whatever, right? Then the very first thing you observe is this 3. Because you have to understand the whole purpose of this De Moivre's theorem is to deal with these powers. Because this power is absorbed. See? So when you see a power, De Moivre's should come here. Oh. Before you do De Moivre's, you have to know polar form. You can't do De Moivre's for this guy.
Yeah.
So firstly, that's a process now. This guy you convert. So it's going to be z. This is going to be, square root 2. I think 6 pi divided by 4, right?
Yeah.
Right? And then 3 outside here like that. Now see, De Moivre is in front of you. So you write this one as 2 half, right? So it's going to be 3 divided by 2. Says, now absorb it. 3 pi divided by 4. Game over. Right? Now I will help you to understand how to convert this into cis form very quickly. Right? Okay? Okay, few examples. Suppose you have z is equal to 1 plus 1i. Suppose. Then how to convert this into this form easily? So you can easily calculate the radius, square root 2. What you have to do is just square it and then take the square root. But this angle, this theta angle you need to find, right? Okay, to find this angle, this is what I do. I can do it like within 5 seconds in this way. Now all these, complex numbers, you can represent in the Argand diagram, right? So if you think about 1 plus 1i coordinates, if you think about the coordinates, that would be 1 and 1 here, somewhere here, right? Yeah. So now you know your angle should be this should be your theta, right? Now you understand if this is square root 2, 1 divided by square root 2, 1 divided by square root 2 is coming. So the angle is 45-ish. That sense we have. And then knowing this in the first quadrant and this is 45-ish, you straight away say it's 45. Okay? Let's think about this one then. Same question, you get 1 minus 1i. Right? So I'm going to put square root here. This here, now angle, right? Now, if you draw it, it should be positive x, that means x positive, y negative somewhere here. See? What is the angle? This way, negative theta. Right? And you know angle is 1 divided by square root 2 is corresponding to a 45 degree, so it's going to be negative 1 divided by 4. That's how we do, right? Okay, another one. Suppose you have z is equal to minus 1 minus 1i. Minus 1 minus 1i. Again you will see this is square root 2, right? Yeah? All good? So, minus 1 is here, minus I is here. So we're talking about something here, right? Now, how much is this angle? We know that that's 45. That's from the diagram.
Yeah.
If it is 45, you can attack it from here. You can take angle, this angle you can take if you want. That angle is going to be 5 pi divided by 4, right? Right? If you want, you can take this angle. that should be minus 3 pi divided by 4. Doesn't matter. So you can write 5 pi divided by 4, or you can leave the answer as square root 2, this is minus 3 pi divided by 4. So that's why you will see in the class, when you get something like that, 2 students will give 2 answers, this one and that one. So then you have to know, okay, this is the same thing, right?